Hello and welcome back to another episode of Math with Sohn. Today we're going to be solving some quadratic systems of equations. So I got three examples for you. The first one is one of the easier ones, even though it looks a lot harder, is a y equals x squared with a bunch of stuff and a y equals x squared with a bunch of stuff. If they're both y equals, then you just set them equal to each other. So if they are both, no matter what system you have, if they're both y equals, you can literally just set x squared plus 5x plus 1 equal to x squared plus 2x plus 1. And it doesn't matter which one's on the left or the right side. It just matters that you solve it from here. Which the first thing you need to do is recognize if you have an x squared and an x, you should start trying to set things equal to 0. And if you start trying to set things equal to 0, if you subtracted x squared from this side and from this side, it actually cancels, which is good news for you, because that means this problem is going to be a lot easier than it previously could have been. Because now we don't have an x squared, and now we need to solve it without factoring, but by just solving an equation. So I'm going to subtract 2x. We would get 3x plus 1 equals 1. Subtract 1. If 3x is equal to 0, then that means that x must be equal to 0. Now, with all systems, you need to make sure that you find the x value and the y value. We have the x value, which sometimes you'll have multiple x values. If we plug in the 0 into either of the two equations, but always plug it into the easiest of them, then we'd end up with 0 squared plus 2 times 0, I'm plugging into the bottom one, which is 0 plus 1. If you do 0 plus 0 plus 1, you get 1. So our solution this time is 0, 1 for our first example. Now the second example is going to be a little bit harder. Each one's going to be a little bit more difficult. The second example looks on the surface like it's going to be easier, but in fact it's probably going to be a little bit more difficult. It will start the same exact way because y equals, you just set them equals to each other. X plus 1 equals x squared plus 4x plus 1, just like last time. The difference is here, when we set it equal to 0, because it's x squared plus 4x, which means you have to set it equal to 0. When you set it equal to 0 this time, you're not going to be as happy because it's 0 equals x squared plus 3x plus 0. You don't need the plus 0, but some people like it. From here, you have to factor to get your solutions. And you can either factor using like the tic-tac-toe method. In this case, it is what multiplies to 0 but adds to 3, and that would be x plus 0 and x plus 3, which actually looks silly in most cases because you could have just factored out an x, leaving yourself with the x plus 3. Now, if you're solving via factoring, then you have to set each of these two factors individually equal to 0. So if we set x equal to 0, we'd get x equals 0. And if we set x plus 3 equal to 0, we would get x equals negative 3. So those are the x values. You need to make sure you keep them organized because with each of these x values, this is going to be a coordinate point. So the 0, comma something, and negative 3, comma something. In order to find the y values, we have to plug the 0 in. Well, if we plug 0 into the easier equation, this is by far the easier equation, 0 plus 1 is 1. And negative 3 plus 1 makes negative 2. So this time we have not one, but two solutions for our final answer, and both of them need to be written as a coordinate point. Okay, so that was example 2. The next problem, this is going to take it a whole different notch. These can go from like mediocre to really hard, really fast, and here's the really hard, really fast. Okay, so what makes this problem harder is two things. First, not solved for y, not solved for y. That sometimes makes it easier because you could potentially use elimination or something like that. What is harder about it is that you have an x squared and a y squared and regular y's and regular x's. If you have x squareds and y squareds, you have to use substitution. You can't really use elimination on these. So first thing you need to do is solve for x or y on, in this case, the bottom equation would be way better. But you could, in theory, use the top equation. And you have to think which variable would be the easiest to solve for. Now, because there's a y squared and a y, I would probably not want to solve for y. But because there's a negative 2 in front of this x squared, I would choose normally not to solve for x either. So both are pretty bad. But if I were solving for y, I would have to divide by 3 to get this y by itself. So that, because I'm going to have to divide by 3, would choose for me to be like, absolutely, I'm not solving for y. I would personally subtract 3y. Like a dum-dum, I didn't do that the first time. Subtract 3y, get x plus 2 equals negative 3y, and then subtract 2. So we get x is equal to negative 3y minus 2. Great. That is what x is equal to. You can then substitute that in for x, all of them, but there's only this one in the other equation. So if we do that, it would be negative 2 times the negative 3y minus 2 squared, then plus y squared, then plus 24y, then plus 76, then equals 0. Which is going to be a pain because you cannot distribute the squared. You also cannot distribute the negative 2. So this is the part that requires some work that oftentimes is annoying. So I'm going to do it off to the side real quick. If we have negative 2 times a negative 3y minus 2, I'm going to write it out twice because you have to FOIL that out. You can't distribute the negative. You can't just distribute that too. So we FOIL this. We get 9y squared plus 6y plus 6y plus 4. And if we have plus 6y and plus 6y, you end up with 9y squared plus 12y plus 4. Multiply by negative 2. Negative 18y squared minus 24y minus 8. And that is this foiled out version of this thing right here. So I am going to now rewrite the whole equation again with the negative 18y squared minus 24y minus 8 instead of this part. But I didn't do anything over here, so I'm going to also continue that y squared, the plus y squared, the plus 24y, and the plus 76, and the equals 0. So I'm just rewriting that. And I'm going to see if there's any like terms, because by goodness, this is as bad as it could possibly be right now. And there is. We got 18y squared, negative 18y squared, and positive y squared makes negative 17y squared. We get negative 24y and positive 24y. Those cancel each other out, which is nice. So we are left with negative 8 and positive 76. Negative 8, positive 76, 76 minus 8 is positive 68 equals 0. And from here, you might have to factor, but in this case, because it's just y squared and a number, it's a lot easier to take this equation, the negative 17y squared plus 68 equals 0. Take that equation, subtract 68. Negative 17y squared equals negative 68. Divide by negative 17. Negative divided by a negative makes a positive, so 68 divided by 17 is 4. Positive 4. And the square root of 4 is 2. So that means that when we square root, we get y equals plus or minus, because we square rooted 2. We are so close to being done. Those are the y values, the positive and the negative 2. We need to find the x values. So we are going to find the x values probably from this equation that I got boxed right here, because x is equal to negative 3y minus 2. So we pick any of the easiest equations that we had to begin with. And if we plug it in, x would equal negative 3 times 2 minus 2. Negative 3 times 2 is negative 6 minus 2 is negative 8. And x equals negative 3 times negative 2 minus 2, excuse me, which ends up being 6 Minus 2 is 4. So our final answer would be right here. It took forever, but you're going to get quicker and quicker at it, and that is the hardest problem you could ever ask for in reality. So here we have our 2 solutions. Stay positive, my friends, and I will see y'all in the next one. Bye.